Maybe more than one time we have seen that a common ceiling fan occasionally generates very strange and noisy sounds, moving from one side to another without control, giving the feeling that in every single instant it will be shot towards us, and that isn't normal, so in a moment we will explain why. Now imagine what would happen if an aircraft turbine blades present this behavior. What would be the consequences? In this video we will show in a concise and simple way how a rotative system reacts when forces not balanced are applied to it. Also, we'll mention the factors that we must take in account to perform a static and dynamic balance for the correct fan's behavior to approach to its optimal operation. When a rotor works in a perfectly way, most of the forces of friction and vibrations disappears and the incidence of airflow against the propellers is ideal. That's the reason of this project, for getting the best rotor's behaviors, eliminating vibrations with static and dynamic balances. But how did we achieve this objective? First, we got a rotation system, one that was useful for the project, in which we could make measurements and analysis in a simple way. In this case, a RAM fan computer was chosen. Before anything, there were measured the RPM, the revolution per minute, given by the 5 volts DC motor for calculating the centrifugal forces acting in the system. As this system was balanced, we had to add several quantified masses in random points in order to eliminate the balance that exists. We could appreciate easily the modification had considerable implications that generate big vibrations that eventually cause noise and oscillations in the fan. Then we proceed to measure the distance from the center of our system toward the position of the previously measured masses. With those data, we had to perform the mainly analysis, the static and dynamic ones, to find the right location where we would place the extra mass to obtain the balance again. How we did it? We found the magnitudes of weights and location of them necessary to return to a state of stability by performing forces and momentum total sums, replacing and clearing up the values of the equations of force centripetal that we disappointed for our system. So we conclude that this analysis and previous calculations are really important for any good engineer who wants to design, create or innovate a rotary system in order to reduce cost and get the best efficiency of the system.